There are several different definitions for when seasons begin and end. The most common definition is that a season lasts from the solstice or equinox named after that season to the next equinox or solstice. Just as a reminder, an equinox occurs on the date of equal daytime and nighttime, and a solstice occurs on the date of maximal daytime for one hemisphere and maximal nighttime for the other. Thus, summer lasts from the summer solstice to the autumnal equinox, that is, from the June solstice to the September equinox in the northern hemisphere, and from the December solstice to the March equinox in the southern hemisphere. The specific date for each equinox and solstice varies from year to year. Why? Because the Earth takes 365.24 days to orbit the Sun, so we even that out by having some years with 365 days and some with 366. So which day a particular location on Earth's orbit lands on shifts around a bit. But on average, the March equinox occurs on March 20th, the June solstice occurs on June 21st, the September equinox occurs on September 22nd, and the December solstice occurs on December 21st. So summer in the northern hemisphere lasts for June 21st to September 22nd, which is 93 days, and summer in the southern hemisphere lasts from December 21st to March 20th, which is 89 days. That's a difference of 4 days. That can't just be a rounding error. Welcome to TwoLambdaPlusBlack. I am Heirua. The Earth's orbit around the Sun is ever so slightly elliptical, about 1.7% deviated from a perfect circle by eccentricity. Earth's perihelion, where Earth is closest to the Sun along the orbit, occurs in early January, on average on January 4th, and Earth's aphelion, where Earth is furthest from the Sun along the orbit, occurs in early July, on average on July 4th. Kepler's second law of planetary motion states, "A line joining a planet and its star sweeps out equal areas during equal intervals of time," which in less technical terms means that, for instance, the Earth moves faster the closer it is to the Sun. 1.7% of eccentricity does not seem like much. You might not even be able to distinguish Earth's orbit from a perfect circle, but its effect on Earth's trajectory around the Sun is noticeable. So the Earth is moving fastest in its orbit around January 4th when it is closest to the Sun, then moves slightly and slightly slower as it moves ever so further from the Sun, until around July 4th, when it is moving the slowest, and after which it inches quicker and quicker again. But January 4th and July 4th aren't neutral with respect to the placement of the hemisphere's summers. The northern hemisphere's summer is aligned with the part of the Earth's orbit where it is moving slowest, and the southern hemisphere's summer is aligned with the part where it's moving fastest. And the difference between the time spent in these arcs of the Earth's orbit is 4 days. You might question if this means the Earth's seasons are more extreme in the southern hemisphere, since if the Earth gets to stack being closer to the Sun with being tilted towards the Sun, there should be warmer summers and colder winters than in the other hemisphere. It turns out that this is not the case. On average, the northern hemisphere has more extreme seasons. Why? The small amount by which the Earth is closer to the Sun in January is not as significant as the fact that the northern hemisphere has much more land than the southern hemisphere, and land's specific heat is much lower than water's. That is, land heats up and cools down faster than water from the same amount of heat. This being said, this average really doesn't say that much, and whichever hemisphere one is in, the ocean and land near the ocean have more tempered seasons, and land far from the ocean has more extreme seasons. Thanks to all of my patrons for funding TwoLambdaPlusBlack. You can join them at patreon.com/Heirua. And as always, remember to love the night.